Hi! In this tutorial, we will learn how to make a complete chess game from scratch. We will learn how to design the complete chess engine that follows the standard chess rules and create a simple AI opponent. So let's get started. We will be using this asset pack from itch.io, which contains sprite sheet for our chess game. This will be the only asset that we will be using throughout the game. The asset contains 2 sets of 6 pieces for each different chess pieces. Each of the pieces are 16 pixels in height and width. The first row contains all the black pieces and the second row contains the white pieces. We will refer to each piece by coordinate system to map the image. The rook in this example is located at 0, 4, and 1 for locations ignoring the pixel shape. Let's switch to Godot 4 and start coding. Let us create the necessary folders for maintaining the scenes and scripts. As you can see, I've already imported the chess sprite sheet into the game scene. By default, Godot 4 blurs out the image, distorting the pixel details from the imported sprites. To disable this, we need to set the texture rendering to nearest. Also, we will set the basic window configuration. The game will contain 2 scenes. The first scene would be the game scene that will have the GUI and the chessboard. The second scene would be the chess piece. The chess piece scene will consist of a sprite 2D object to load the texture. Since each of the chess piece in the sprite sheet is 16 x 16, we will set the same in the texture rect region. This will display the king piece by default. If we need to change the sprite based on the piece, then we need to set the appropriate starting x, y coordinates. Next, we will create a global object to keep track of the constants in the game, like the enums for piece colors, piece types, current player, and initial starting positions for the game. Setting this enum constants will help us to easily do comparison for the different chess game states. Let us add the scripts to the game node, board node, and the chess piece node. These scripts would form the core for the chess engine. We will now declare the variables for the board. We will use a simple array to keep track of what pieces are available in the game. The individual items in this array corresponds to a chess piece instantiated dynamically during the startup. Also, we will keep track of the positions of the king pieces throughout the game in order to evaluate check or game end logic. First, let us start with drawing the chessboard and cells for the game. Each piece will position on top of each cell. These cells in the board consists of alternating black and white colored cells, so we will generate each of these cells dynamically during the startup. For drawing the cell, we will create a color rectangle texture and set a 60 pixel height and width, with an alternating texture color based on the cell coordinates. We will use the cell coordinates to also position it within the game scene. By setting a z_index of -10, we are pushing the cells to background layer in UI. Now we have a basic chessboard ready. Feel free to customize the cell colors as per your taste. Also, let us adjust the window viewport to fill the entire chessboard and scale up the canvas size. In order to map the sprite image with the chess piece, we will make use of this dictionary mapping. The mapping maps the chess piece in color to the appropriate sprite position for the chess piece. We have ignored the sizing of the image here, as we will calculating it during the chess piece initialization. We also have this constant list that contains the initial position of each chess piece. The position are defined for the black piece mainly, but we can get the white piece positions by calculating the opposite board coordinates. Let us create the script for the chess piece that maintains its state variables like what piece it is, and what are its position in the board. The init_piece method will help to initialize the piece by updating its piece type, color, board positions, and the sprite. Next, we will go back to the game board and start creating the pieces. We will refer to the constant position list that we defined earlier in the globals. If you want to start the game with different configuration, then you can modify this list or the method. As mentioned before, the list maintains the position for the black pieces. We will calculate the position of the white chess piece by subtracting its y coordinate from 7. In order to track the king piece positions separately, we will create a register_king position that will be used to update the king piece positions whenever they are modified. Now let us start writing the main logic for the game. We will define few variable states that keep tracks of what is the current active color, what is the player 2 status, etc. In order to move the pieces, we will override input event. The idea behind the dragging functionality is that at first we need to detect the piece that has been selected. Then we switch the mouse event to dragging, where we move the piece with the mouse. Once the user releases the mouse click, then we will check on what coordinate is the mouse was on when releasing the press. This release position is the target position on which we evaluate whether the piece can actually move to this position or not by series of tests. If on release, the target position is a legal move in the chess game, then we move the current piece position to the target position. We also update the new piece coordinates and delete any piece that was present on the target location as part of a capture. The move position helps to update the new board coordinate for the piece after the move. We will also define a delete piece helper method on the board in order to delete a specific piece from its internal array and free it from the memory. Once a piece has been played by a player, then we need to change the current active color by updating the status variable. We need to also make sure that the variables tracking king positions are updated as the chess piece are moved. When a pawn is moved to opposite end, then we can promote. We will create a simple promotion logic that will upgrade any pawn that reaches opposite end to a queen by default. Each piece moves in different manner. Basically, there are two types of movements in chess. One type of move involves in a straight line either diagonally, vertically, horizontally. Some piece can move to the immediate location or a specific pattern. To identify what valid moves are possible for each piece types, we will create two helper functions for different chess piece movements. The beam search looks up positions that are in straight line in specific direction. When traversing in a direction, if we hit a specific piece, then we stop the search. Similarly, we will create a spot search method that will look for valid moves for pieces like knight, pawn, and king that moves one or two positions. In order to validate moves on the board, we will need to apply the move onto the board and validate for any checks or illegal moves. For this, we need to duplicate the game board and its pieces uniquely. Godot has a duplicate method on its node object, but unfortunately it doesn't clone the data uniquely but rather uses references to copy things like array or dictionaries. To solve this issue, we will create our own clone method that will duplicate board and copy the values uniquely by pieces. In the valid check, we will first clone the board. Then we will evaluate whether the move is available in the piece's valid move lists. Then we move the piece to the new position in the cloned board and then validate for any checks or illegal moves. We will create two methods in the piece object that lists down possible moves that leads to threat or valid moves. The method is an entry point, and further it will route based on the piece type. First, we will define the rules for the pawn movements. A pawn in chess is allowed to move 1 step forward or 2 steps if it's first movement. In both the cases, the movement is only allowed if there are no piece blocking its movement. Also, the pawn can capture other pieces by moving 1 step diagonally. The bishop moves diagonally across the board as long as there is no obstruction. It can capture other pieces if they are in its path. We will use the beam search method to capture the moves. The rook moves in a straight line either horizontally or vertically. We can reuse the beam search here as well. Knight in chess has a unique movement. It moves in L pattern across all directions. To evaluate the moves, we will use the spot search. Queen moves in straight line across all directions. Its movement is a combination of bishop and rook. Finally, we will create the rules for the king. King has a similar movement pattern as a pawn as it moves one step in all direction. With this, we have all the rules for the chess piece defined. Currently the game has no endgame as to who won with a checkmate. In order to decide the wins, we need to check for all possible moves available from all pieces. If none of the moves are available after a piece move, then that means the king is in checkmate state. We will create a get_valid_moves method that will help to find out all possible moves available in the board. This is useful for two reasons. 1. We can use the empty condition to evaluate a checkmate. 2. We can use this to decide on a move for the AI. At game end, we will evaluate the current status value to decide whether the player 1 or 2 has won the game. Finally, to finish the project, we will create a basic UI that displays when the game is over and reports the winner. Also, we will add a button to restart the game.